Everyone. In our previous video, we have installed Mintpy and learned about some important files such as interferogram stack, geometry, geo, time series, and velocity H file. Now, a very common beginner question is, where do we get the initial files? That means, where do we get the Sentinel-1 imagery? Do they come with Mintpy, or are they generated by any other software like this? So in this video, we will understand the complete InSAR workflow from satellite acquisition to Mintpy processing. So here, if you see the picture like this, we have Sentinel-1. From that, we are extracting only the SLC images, and then we are going for the ISCE to processing, and then we are generating the interferograms, and we are giving the Mintpy inputs, and in Mintpy, we are doing the processing. From there, we are getting the time series and velocity maps. So the first thing is Sentinel-1 data acquisition. So Sentinel-1 is actually a radar satellite that is operated by the European Space Agency (ESA). So unlike the optical satellites like Sentinel-2, okay, Sentinel-1 can work day and night, and it can see through the clouds also, and it is able to operate during the most worst weather conditions. So this makes Sentinel-1 extremely useful for landslides, subsidence, volcanoes, and also infrastructure monitoring. Now, the question is, how do we download and what we should download? First thing is, we are not directly able to download the velocity maps because they are not available. We do not download the deformation maps because they are also not available. They have to be processed. So what we do is we download the SLC images. That means single look complex images. These are the raw radar images. Say example, I'll show you this website. In this Copernicus browser, you can just go to any criteria or any location. In that, if you see clearly, there is Sentinel-1, Sentinel-2, Sentinel-3 like this. So Sentinel-1, I want to go for Sentinel-1. And in this, I wanted to go for SLC, single look complex. And using this polygon marker, I mark one area of my interest, and then I'll go to the bottom and I'll give a time range. Say example, it is 23rd May 2026 to 23rd June 2026. Now we just go for search. This will take some time because it should show all the acquisitions. So if I zoom out clearly, then you can see these many acquisitions are taken place during the time period. Now, I have to focus only on my study area. See, this particular image is covering the whole study area. Even this is not covering, this is not covering, this is not covering, this is covering. So, what I can do is I'll just click on one image, and here you can see there are several images in which the data is collected. So you need to have exactly the same acquisition types. It should not be like one here, one there like this. So in this particular category, you need to select which one is your study proper data. Okay, so I have this one. So I can click on download and that will be downloaded. The same way I can go to the other acquisition like this again, and then I need to check whether which one. See again, this is there 2026 um, June 12th, and the other one is 2026 June 19th, and again I have 2026 June 7th. So I have the data. So I need to download the particular data, and that too in a given period of time. Like example, if I wanted to do a study from 2026 to only for 1 month, then I have to collect all the data that is available in 1 month. If I want to go for years, then I have to change the filter, and then I have to go for larger number of data sets. Okay, so like to the beginners, it just looks like a normal image. But when you go for the interpretation part, then the phase, the amplitude information, whatever you're getting, it is something more valuable. Now, why we are taking more data for subsidence monitoring? Because to measure deformation through time, that means from example 2017 to 2025. So that data is more valuable than when you do it for 1 or 2 months. So at least if you have 50 to 60 data sets, then it will be good. But I suggest you to go for more. Then only you'll see the clear data changes in that time Mintpy or any other software. So as we are discussing about Mintpy, we'll also see why Mintpy cannot directly read the Sentinel images. That is because many beginners usually think that Mintpy processing is done directly using the Sentinel-1, but that is not the thing because Mintpy uses only interferometric products. That means with these images, again you have to create interferograms, and from that interferograms you have to go for Mintpy processing. So the Sentinel-1 and Mintpy, in between these, you have the ISE2. So ISE2 is it's a InSAR scientific computing environment in which it will convert the sentinel images into products that are suitable for deformation analysis. Like you can get the interferograms and all. Now, when you are using ISE2, what it can generate is first it will co-register the images, and then it will create the interferograms, and from there it will do the geometry calculations and also the coherence calculations. Now these outputs are used by Mintpy for the processing. Now you might be knowing this already, but I'll just tell you again. Interferogram is something like it will take two images and then it will measure the phase difference between the two equations. So these phase differences contain information like the ground movement, the atmospheric effect, the noise, and also the residual topography. This is one important thing which you listen all the times during any kind of satellite data processing, interferogram, and then coherence. Coherence is also one of the um, important topic. So coherence will tell you how reliable a pixel is. Like higher coherence gives more trustworthy measurements. If the coherence is very less, then it may or may not be able to give you properly. So you need to understand the coherence values also. Now, after the ISE2, it will give you the interferogram stack and the geometry geo, like I have explained you in the previous video. So these are the important files for Mintpy to start the processing. Now, again, I'll just explain you from the previous video. The interferogram stack contains interferograms, coherence, phase information, and also the acquisition date. If you go to the geometry, then it has latitude, longitude, incidence angle, and the elevation information. Now, most important thing is how this processing happens in Mintpy. So, only now does Mintpy will enter the workflow, and Mintpy will does not create any new interferograms. It uses only the existing interferograms. Mintpy will analyze only through the time. That means from a time interval between 2017 to 2025. That analysis will be done by Mintpy. And finally, you'll get the outputs like time series and the velocity. Here, what will happen? These files contains the deformation history. That means the whole subsidence or upliftment or whatever movement is there. That history will be given by these time series and velocity, and then also the velocity estimate and also the ground movement trends. So here, what happens is commonly the beginners think that Sentinel-1 and then directly go for Mintpy. It's like that. But it is Sentinel-1 and then you go to ISE2 and then you go for the Mintpy. This single concept will save months of confusion. And in the coming videos, I'll also explain you how to directly download the interferograms instead of doing all the processing. So there are many websites like Alaska ASF datasets in which you can select your data sets, and then you can directly ask for the MinPy compatible outputs. From there, you can directly get the data, and then you can use it in MinPy directly. So from here, we are going to have a practical data preparation, everything. So please do watch other videos, and please do let me know through the comments if you have any queries. Then we will discuss, and then you can have a clear experience of what is Mintpy and how to do the processing. So thank you, and subscribe to Geoscience Engineering.